All right. So, looking at this one, this question was a little bit different than what what I was asking you to do yesterday. Um, yesterday was all theoretical, um, theoretical molar masses, and it was based off of knowing the formula of it. This one, we don't know the formula. We just know that we have a sample that contains iron and oxygen. And so this one is an experimental. So we approach experimental a little bit differently than we did um, the theoretical like we did yesterday. So I know I have a compound that contains some ratio of iron and oxygen. So my subscripts on this one, I don't know them, so I can't get a molar mass. So I have to find a different way to approach it. So on this one, I know I have iron in it, and I know I have oxygen in it. What I know about the iron is that I have 1.26 grams, and what I know about the oxygen is I have 0.54 grams. The other thing that I can find out is I can find out a total mass of the sample. And so the way I do that is just add them together. So I have 1.80 grams of sample. The nice thing about percentages, I don't have to know the molar mass as long as I know the total masses of everything that I had. So percentages, whether I did this based off a chemical formula or whether I base it off of this, the percentages are going to come out the same. So I can take for percent iron, I can take my 1.26 divided by 1.80 multiplied by 100, and that tells me that I have 70% iron. So this compound is going to be 70% iron. And then this compound would be 30% oxygen. All right. Now, again, there's some other steps, and we'll actually be looking at this tomorrow. There's some other steps knowing this information that we could take to get the actual formula of it. So we can find out the formula based off of this, but we'll just have to, there's some other things that we have to learn before we can do that. So I just want the reason why I pulled this one up there is I wanted you to see there's different ways of asking questions about molar mass and percent composition and things like that, that they're not all going to be as straightforward as you expect. All right, so today we're going to be taking some of the concepts that we were doing yesterday, like I introduced yesterday in the video. I introduced that 1 mole of a substance is all right. So yesterday we saw that 1 mole of a substance is 6.022 times 10 to the 23rd particles. We're going to be using that today, but we're going to be expanding on what we can compare a mole to. So our goals today is to be able to use molar mass to convert between mass and moles for an element or a compound. But we also need to be able to go the other direction. I need to be able to go from moles to mass. All right. And then the other thing that we're going to be able to do that we're getting to is using that mole ratio and molar mass to determine. So for example, if I have 1 mole of CH4, that means I have 4 moles of hydrogen within there, or 4 hydrogens inside that compound, and understanding that. All right. So we're going to be doing a lot of different little conversions today. We're going to do some one-step conversions and some two-step conversions as we go through this. All right, so now, oops, thought I erased that. All right, so the first thing that I want to identify, because I mentioned we're going to be using Avogadro's number. Which again is that 1 mole equals since we're going to be using that number that 1 mole is equal to 6.022 times 10 to the 23rd particles, we need to identify what we classify as particles in this class. So whenever I talk about particles, I could be referring to atoms. If I have a singular element, I'm probably going to be referring to atoms. So atoms would just be like a singular element, like atoms of copper or something like that, or atoms of zinc or atoms of aluminum. All right. I could be referring to formula units. So graphically, it kind of looks like this. So I have an NH4 ion and a chlorine ion. So those two ions form the compound ammonium chloride, NH4Cl. All right. If that's when I'll use formula units whenever it's in so if I'm talking about an ionic compound, when I refer to particles, I'm referring to the formula units of that. Molecules would be for covalent compounds like water. So molecules is always going to be related to covalent compounds. So if I ask about particles of a covalent compound, your unit would be molecules then. And then back to ionic compounds, we could also ask for individual ions within a compound. So if I have some ions, some positive and negative ions, and I ask specifically about the chlorine ions, we can determine the number of particles or ions in that solution based off of that. All right. So as we're going through today, you're going to find the notes are not going to be a whole lot. It's going to be more practice problems today. This chapter and the next chapter will probably be more like practice problems as we're going through it, because there's not going to be a whole lot to write today, and because it's really just applying skills that we should already kind of have. All right, so what we're going to be expected to do, what Southeastern is going to ask us to do, what the professors, what any type of questions we see, they're going to be asking us to convert between volume and mass, mass to moles, moles to particles, or be able to go the other direction where we go from particles to moles, moles to mass, mass to volume. All right. So starting off with volume, we started with volume actually very early in this semester. If I need to get from volume to mass, what do I need to use? I heard it, density. We're going to use density to get from volume to mass, because remember that density is grams per milliliter. So if I'm in volume, I'm in milliliters, I can get rid of milliliters and I can go to grams then. All right. Now, yesterday we started playing with this. If I want to get from mass to moles, what number am I going to need to use? Not Avogadro's for mass to moles. What were we calculating mainly yesterday? What is something that has, okay, so let me ask this question. What unit is mass typically measured in? Grams. All right, and so do I have a unit that includes grams and moles? Grams per mole. And what is grams per mole? Molar mass. So to go from mass to moles, I'm going to use molar mass, because the molar mass of something, 1 mole of that substance is equal to that mass. So there's a relationship between moles and molar mass. All right. And then, now, notice I can go from volume to mass using density, and I can go from mass to volume using density. I can go from mass to moles using molar mass and moles to mass. I cannot go directly from moles to volume. All right, and I cannot go directly from volume to moles. I have to take that step there. So the same thing's going to apply on this next one. If I want to get to particles, now comes up the one that y'all were trying to say before. What number am I going to have to use to get to particles? Avogadro's number. All right, so remember, Avogadro's number states that 1 mole of a substance (10 to the 23rd particles. And remember that particles can be atoms, ions, molecules, formula units, any of those things, and it depends on which one's the appropriate one at the time. So looking at these and looking at what's going on, I'm going to be using one of these things, because I know that whatever grams of my molar mass is equal to 1 mole of that substance. So I can use this as a conversion factor, I can use density as a conversion factor, and I can use that as a conversion factor. So all of those are conversion factors that allows me to get from one place to another. But know that if I'm starting in particles, in order to get to mass or volume, I have to go through moles. So I can go from particles to moles, and I can go from moles to particles. I can go from moles to mass or mass to moles. But I can't jump. So moles is really kind of like my translating unit for everything else. All right, now, dang it, let me go back. All right. Now, so let's look at this as some problems. So, looking at this first question, it says how many moles are in 14 grams of calcium chloride? So, this question, and using the little flow chart that I just gave you, this question, what units are we going from and to? We're going from mass to moles. So what's the first thing that I'm going to need to figure out to get from mass to moles? Molar mass. So I need my molar mass to be able to figure out how to convert from one to the next. So looking this up, whenever you solve for molar mass, I know the worksheet that I gave you yesterday said to go to the tens place. what I'm going to ask from this point on, always go to the hundreds place when you pull a number. So always go 2 decimal places off the periodic table. What that's going to save us from, making sig fig errors based off of our given. I want our given to drive our sig figs most of the time. So if we always go 2 decimal places with molar mass, then it won't bother stuff. All right, so I have calcium, which I have a mass of 40.08. I have chlorine, which I have 2 chlorines, which gives me a mass of 70.9, and I'm going to say 70.90 in that case. So I add this up, and what do I get? 110.98. All right, now that's my molar mass, and that's in grams per mole. So, yes. In this one, I'm maintaining 2 decimal places because I'm adding. All right. I haven't used that number yet. I used 40.08 off the periodic table, and I used 35.45, so 70.90, and I added them together. All right, now I have my 14.3 grams of this. How do I use that molar mass here to get to moles? All right, so for every 1 mole of this, I have and that allows me to get rid of grams. So go ahead, take a minute. So what should I come up with for my moles of CaCl2? All right. So looking at this, my 14.3 is in 3 sig figs. I'm taking 14.3, dividing it by 110.98. And so what do I get for my answer in 3 sig figs? 0.129 moles of calcium chloride. All right. Now, based off of what we just did, see if you can solve this one. So in this one, it asks how many grams will 0.093 moles of calcium phosphate weigh or have. So the first thing you're going to have to do, no matter what, is get molar mass in this. But the equation is not going to be set up the same. Yes. Okay, so watch the video that I post. All right. So again, on this one, this time I'm going from mole to mass. So this time I want grams on top and moles on the bottom whenever I do my conversion, but I still have to get my molar mass. So I have calcium, I have 3 times 40.08. So I get 120.24. I have phosphorus, and I have 2 phosphoruses, so 2 times, what is phosphorus? 30.97. And then I have oxygen. I have 8 oxygen, so 8 times 16.00 gives me 32.00. So I get, yes. Oh, duh. Sorry, I put in the wrong. My brain just went. I thank you. Thank you. 8 times 16 is not 32. And believe it or not, I have the right number sitting right in front of me, and I still wrote down the wrong number. All right. So you should get a you should get a molar mass of somewhere around 310.18. On that. Now we got to figure out how to plug it in. So I'm starting off with 0.093 moles. All right, so I'm trying to get 2 grams, so my grams is going to go on top. Mole is going to go on the bottom, so for every 1 mole, 310.18. And so what do we come up with, and how many sig figs am I going to use? 2 sig figs. So you should get 28 point something, something, something. That's going to round to 29. All right. All right. So that's examples of one-step conversions where we're going from mass to mole, or mole to mass. So notice that I always set it up so that I can get rid of whatever unit I'm in and go to what unit I'm trying to go to. Now, so what I'd like for you to do is, if we assume that I have 100 grams of each of these things, I want you to go ahead and solve these based off of 100 grams of each.